So this section is talking about some of the built-in algorithms in C++ inside the standard template library and how these algorithms rely on the use of iterators. So I'm not going to really dive too deep into the different algorithms there because there's tons of them. Um, but basically, in order to use those algorithms, just the first thing that you want to know is that you'll need to use the include, and then that would be algorithm. And then depending on which algorithm you're using, will determine what inputs you need to put in those arguments. And usually those inputs are going to be iterators. So inputs are going to be iterators. And so I'm just going to kind of go over the different type of iterators that we have. And so the basic idea of this section is that it's explaining how the different type of iterators work and how they're used as inputs for algorithms. But it's also saying if you wanted to create your own container class and you wanted to use some of these algorithms that are built into the standard template library, you could do this with containers and classes that you create yourself as long as you implement the different type of iterators properly so that these algorithms will be able to use your data structure, your class, or your container that you developed yourself properly. So let's go ahead and talk about the different categories of iterators. Categories of iterators. And your secret word today is pickles. All right, so the first one is going to be an output iterator. All right, and so this is pretty much your iterator has the ability to actually output some data. And considering that your iterators are pointers, right? And let me just put a side note here, right? Iterators are pointers. Right, so what we know about pointers, if we want to get some value from a iterator, and knowing that an iterator is a pointer, then we know that we have to use the dereference operator, right? So we need to use the dereference operator. Right, so if we create an iterator and we use the dereference operator in it, then we are going to get what that iterator is pointing to, right? And that's going to be our value, right? So in order to have our own data structure do that, that means that we must overload this particular operator, right? So, so let me just write that down. In order for our own class to output, we must implement the dereference operator. Let me not say implement. We must overload the dereference operator. My spelling is off. Sorry. The dereference operator. All right, so that will be our input operator, and that's for so that we can do something like this. Say we have an iterator, right? And if our iterator was called iter, it'll be something like this. Dereference iter, right? Let's just say we want to see out that, and that will give us whatever. This returns whatever value. Let me not use that arrow since we're talking about pointers. this returns whatever our iterator is pointing at. All right, so the next thing that we need to have inside type of iterator that we need to have is the input iterator. All right, and so the input iterator will also require the dereference. Right, this also requires a dereference. Right, and so that is so that we can, if we had some variable x, that we would be able to actually set it to whatever the iterator is pointing at. Right, so that's pretty straightforward. Right, that's just dereferencing. If it's our pointer and our pointer's pointing to our data, then in order to get our data, we just use the dereference operator. All right, so the next one is going to be our forward operator. Our forward iterator. And that is pretty much makes our pointer move to the next item inside of our container, right? So in order to do that, we need to use the plus operator. Right, this actually, if our iterator is called iterator, then we would do something like this, plus iter. And so now it's going to point to the next element in our list, our container. All right, so let me just write a note to that. All right, and then the next one will be a bidirectional iterator, right? So if we have a bidirectional iterator, then that means that we can actually do the plus, or we can do minus. And that means that the iterator can access the next element in our container, or it can access the previous element in our container. All right, so it can access next item in our container, or the previous. Right, so as long as your container has these two operators overloaded, then you would be able to classify your iterator as a bidirectional iterator. All right, and then the final one is a random iterator. And this is basically overloading the brackets, right? So that you can use array notation on your iterator, right? You could do something like this: iter and then some number, right? Iter some number equals, and let's just pretend this is a data structure that holds integers. So I can say something like iter at element 3 is equal to 12. Right? In order for us to do that, then we must overload the brackets operator. All right, and what this does, it doesn't quite work the way we're used to array notation working, where previously if we had an integer array, right, and let's say we set it for 5 elements, then when we do something like this, array 0, we're actually referring to, right? This actually refers to the first element. Right? But that's different when we're using iterators, right? So if we had an iter and we did something like this, right? Say iter is our iterator. This does not refer to the first element, but it refers to the first element related to where the pointer actually is, right? So that means that will be the current, right? This would be the current element in our container. What that means is, as I mentioned before, we have forward iterators and bidirectional iterators, right? So if we have called the plus plus operator several times, then we're not at the same place. We're not necessarily at the first element in our container. We could be at the third or the fifth, right? So when I say iter 0, it just means wherever the iterator is pointing to at now, then I want that current element that it's pointing to. If I did something like this, iter 5, this means give me the fifth element after the current element, right? So the fifth element from the current, right? So this doesn't necessarily mean the fifth element inside. Well, that would be the sixth, right? This doesn't mean the sixth element inside of the other, right? This means the sixth from where we are. So it does not index the data like we normally would see it with an array. All right, so that is pretty much that's pretty much what the section is actually referring to. It's just kind of giving you a setup of what needs to be implemented if you want to be able to use your defined classes and containers and use some of the built-in algorithms that the standard template library comes with. So we'll go deeper into how to implement these in the next video. All right, thank you very much.